This lesson is Geometry Chapter 2-5, Reasoning in Algebra and Geometry, and we have all of these properties to discuss, so this is going to take a little bit. Here we go. If A equals B, then if we still have A is equal to B, and we're adding the same value to both sides of the equality, we maintain that equality. So here's an example. You got x minus 5 is equal to 13. Well, if we add 5 to each side, and I'm going to copy the rest of the equation. So we now have the same original equation, and we're adding 5, the same value to each side. Then we are canceling out this negative 5 with a positive 5, and so you have x is equal to 18. All right, next example. Subtraction property. So if you have a is equal to b, a is still equal to b, and you're subtracting the same value from both sides of the equality, you're still maintaining that equality. So we have x plus 4. Well, if I copy the x plus 4, nice handwriting, let's try that, is equal to 1. And then you subtract 4 from each side of the equation. We're still maintaining equality. And then we're going to get x is equal to negative 3. Okay. Multiplication property. If a equals b, you multiply both sides by the same value, you still maintain equality. So if we start out with y over 3 is equal to 11, if we multiply both sides by 3 to cancel out this 3, and both sides, when you cancel it out, the way you're canceling that out is that 3 divided by 3 is really a 1. So you're making it 1y is equal to 33, which is just y equals 33. Okay, next one. Division property. If a equals b, you're allowed to divide both sides of the equality by the same value, provided that that value is not equal to 0, because we're never, ever allowed to divide by 0. That's undefined. So if you start out with 4x is equal to 28, if we divide both sides by 4, so you wind up with x is equal to 7. Reflexive property. Pretty straightforward. Something is equal to itself. So x is equal to x, 5 is equal to 5. Congruence in a second. Well, in a minute or two. Okay, symmetric property. If you take is a equals b, you then flip the order and say b equals a. So if you say x is equal to 5, 5 is equal to x. Transitive property is going to be that if a is equal to b, b is equal to c, and then you can just make the jump of saying that you're going straight from a to c. So my example is if y equals z and z equals 7, you can go right over here, say y is equal to 7. That's done. Substitution. If we take this original equation here, well, we got two different equations here. X plus y is equal to 7, and 3x plus 2y is equal to 20. And if you take the top equation and subtract x from both sides, you get y is equal to 7 minus x. This value here, the y, you can substitute that into y for the other equation. So then you're going to get 3x plus 2, and then all of y, which is really 7 minus x, is equal to 20. And then you can solve that for x. So you get 3y, you distribute, so 2 times the 7 is 14, 2 times the negative x is negative 2x. So what do we get? We get x plus 14 is equal to 20, and subtract the 14 from both sides, you get x is 6. Okay. Distributive property. Well, now we're talking about distributive that we just did a moment ago. This is 3 times everything that's inside these parentheses, so you distribute that. So I'm sort of making like fishing casting lines here. Same story here, even though there's a subtraction here. You are distributing it. So this is going to turn into 3x plus 3 times x, 3 times 2 is 6. So you get 3x plus 6. This is going to be 3 times x is 3x. And 3 times a negative 2 is going to be negative 6. So you get 3x minus 6. Now, in some of our proofs, they're going to say that when you're really combining like terms, they're going to say that that's distributive property. So if you have 3x plus, well, excuse me, the original statement is that in the distributive property, before we showed that A was distributed to B plus C. Well, we're going to take that backwards. Take that result. Look, A times B, A times C. And we're going to recognize that and factor out the A. So in this case, I've got 3x plus 2x minus 11, and I want to combine like terms. Well, you can factor out the x. There's the x. So it's really x times 3 plus 2, which combines to 5, which then that's really 5x, and I still have this minus 11 along for the ride here. So what we quickly say in geometry class, in our algebra class, we were saying that 3x plus 2x, we combine that into a 5x and copy the rest of the expression. Our textbook describes that process in a proof as distributive property instead of what we used to call combining like terms. Okay, properties of congruence. Sometimes, a lot of times in geometry, we wind up saying that something is congruent to itself, which is the reflexive property. And in this case, you have this line illustrated in red, AB, line segment, AB, and it is shared between these two triangles, which is going to be really helpful to prove that those two triangles happen to be congruent. So in our proof, we are going to say that AB is congruent to AB. And then we're going to say, after we get that done, we'll be able to say that these two triangles are congruent by the side-side-side congruence postulate. So, yeah, let's keep going. Okay, reflexive property. Angle E is congruent to itself with angles as well. And in this case, we have two triangles shown in this image, and I broke it up into two triangles. We got the little triangle here that was at the bottom here, and we got this big triangle that I've shown over here to the right. And see, they both have the same angle E. So E is congruent to itself. Symmetric property. That's more notation. You're saying that if AB is congruent to CD, then you can switch the order and say CD is congruent to AB. And likewise with angles. You can say that if angle E, 1 mark, is congruent to angle F, 1 mark, then you can switch the order and say angle F is congruent to angle E. The transitive property is, let me get a highlighter. If you say AB is congruent to CD and CD is congruent to EF, then we can just make the jump and say that AB is congruent to EF. And if angle A is congruent to angle B and angle B is congruent to angle C, then you can make, transitive property allows us to say that angle A is congruent to angle C. Okay. Now, writing out proofs, I grabbed this proof, I copied it. We're not going to write out each step because if I write out each step, this video is going to take forever. So, right now we start off with this image here, and that these two angles here are a linear pair. So, try to use two different colors for highlighting. So, this angle here is angle AOM, and this angle here, MOC, there you go. So they add up, they're a linear pair, and they add up to 180 degrees, and my pen seems to have vanished. Oh, no, I'm back again. So well, we're going to say the measure of angle AOM plus the measure of MOC is equal to 180, linear pair. To the left is our statements. To the right is our reasons or explanations. So we need a definition, some reason to say why these two angles sum up to 180 degrees. Well, it's the definition of supplementary angles. Supplementary angles add up to 180 degrees. And I got this little 1 right here because I'm citing that I'm grabbing the information from line 1 and using it in line 2. Right. Now line 3, this expression, 2x plus 30, wound up being substituted in place of this notation for the measure of angle AOM. And likewise, this expression x is substituted in place of the measure of MOC, and then the 180 was brought down. So this is the substitution property. And I'm really using information from the previous line too, so that should go. Okay, so let's move this down one. Well, I'm combining like terms, which, as I described a little bit earlier in this video, our textbook uses the statement of distributive property to justify that, so that's why we've got that statement there. And then the next step is, see, we subtracted 30 from both sides in order to get from line 4 to line 3. So we're going to say subtraction property here of equality, because we subtracted the 30. And then now we divided both sides by 3 to solve for x. Now the last step in every single proof is going to be what it is that they're asking for. So here they're asking for the value of x, so then that's the last thing in this proof. Okay, so we're given that A, B, C, D in the image are all collinear points, and that you're given that AB is congruent to CD. So, and then we're supposed to prove that AC is congruent to BD. And what we're aiming for, the skill in writing proofs, and here we go, my pen's being a pain again. Here we go. If AB is congruent to CD, and we have this commonality here, this overlapping region of BC, need to visualize that if this had the value of 10 and this had the value of 10, I'm just making up numbers, that then if we have the commonality of BC, and I'm just going to say arbitrarily that it's 6, 10 plus 6 is 16, and this 10 plus 6 is 16. So we're going to use the concept of taking this congruent length and this congruent length and adding this length that's in common to both of them, which will allow us to say that this line segment is congruent to that line segment. So let's look at the proof. So here we go. So AB is congruent to CD. That's the given information. So here's our statement. Here's our reason. Let's move this down. And we know that if segments are congruent, then they have to be of equal length. So I wrote that. I got that information from the first line. Move this down a little bit. BC is the reflexive property. This is what's in common. Well, BC is congruent to itself, and it's going to be in common to these two line segments. So here we go. So if you take the AB that we got here and the CD, this equality, and that's really being copied from line 2 down to line 4. Look, AB, CD, that's in common. And we're adding the same thing to both sides. So therefore, that's the addition property of equalities. And you're taking the statement from line 2, and you're adding the BC to both sides from line 3, and that's how we produced line 4. That's why I put this notation here of 2 and 3 on the side there. Let's move this down. Now, what I'm doing here is I'm saying that AB plus BC, which we've already got, is equal to the total length of AC. This value of AB plus the value of BC is equal to the length of AC. And then going the other way, CD plus BC, we have that CD plus BC is equal to the total length of BD. So that's segment addition property. And then, let's move this down a little bit. Nope, the screen jumped. How about we get rid of this? Okay, and we'll move the screen back up. Okay. Now, I'm substituting this AC in place of this value here on line 4. That's where this comes from. And BD is being substituted in place of CD plus BC on the right-hand side. So that's strictly substitution. And we're grabbing the original statement on line 4, substituting the information on line 5 to create line 6. So that's why I got a 4 and a 5 right there. And once we say that those two segments are equal in length, then we can conclude that they are congruent. Segments of equal measures are congruent. So that proof is done. We're supposed to write a 2-column proof on this one. Let's see. We're given this image, and measure of angle 1 is equal to the measure of angle 3. So this angle 1 is congruent to angle 3. I got the little congruent marks there. And we're supposed to prove that AEC let's go to the highlighter here. AEC, all of this is equal in length, equal in measure to all of this. So what we're going to do is we're going to recognize that this angle here in yellow is equal in measure to this angle over here, and that this angle 2 in the middle here is shared between this large angle here and this large angle there. So we're going to say that this plus this measure is equal to that plus that measure. So let's look at this. Let's look at these statements one by one. Measure of angle 1 is equal to measure of angle 3. That's given. Measure of angle 2 is congruent to itself. Reflexive property. Now, we still have this statement number 1. Measure of angle 1 is equal to the measure of angle 3. And now we're adding the same thing to both sides. So this is the addition property of equality. And now we're saying that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 1 plus the measure of angle 2 is AEC, that angle, that measure, and the measure of angle 3 plus the measure of angle 2 is equal to the measure of angle DEB. And then the next step is to substitute this in place of these two sides of that equality. So when you substitute the measure of angle AEC in place of what's here, angle 1 plus angle 2, and you take the measure of DEB and substitute that in place of the measure of angle 3 plus the measure of angle 2, then we're done. And that's it. Thank you for watching this demonstration.